Welcome everyone to this webinar. Thank you to everyone for being here, and also special thanks to our friends of the Pipeline Industries Guild for allowing us this platform for the webinar. If you don't know me, my name is Alex Paleologos. I'm the International Business Manager for McElroy. I work alongside Malcolm Profit, who is our Technical Service Specialist, and we both look after the UK market. I joined recently, McElroy. I joined in September last year. And although I'm new, I'm not that new to McElroy. Previously, I worked for our McElroy distributor in Mexico for over 4 years. And I've been living in the UK for the last 6 years, working as an engineer for the automotive and the motorsport industry. So very happy to be back with McElroy, very happy to be back with the pipelines. And today we have a very special guest. We are joined by Chris Greggs from our headquarters in Tulsa, Oklahoma. Chris has a vast experience in McElroy machinery and HDPE fusion. He has over 30 years working for McElroy, and he has contributed to the development of our original Trackstar machine. But most recently, he has been our product manager for the Trackstar I-Series lineup. And nowadays, Chris is our product manager for the Tritan 560. So any question you have for Chris, this is the best time. And without further ado, just a bit of housekeeping. If you're not presenting, please make sure that your camera is switched off and your microphone is set to mute. And if you have any questions, feel free to use the chat function, and we will have a Q&A session at the end of the session. So yeah, without further ado, I'll leave it in your hands, Chris.
Oh, Alex, thank you very much. And thank you again to the Pipeline Industry Guild for giving us this opportunity, and to our guests for your time. We are really excited to share with you this morning. If I can get my technology to all work here. So we're going to talk about the Tritan 560 this morning. This is an all-new machine, and it's truly a revolutionary concept in how we approach the fusion welding of plastic pipe in the field. Now, as you look at this machine, I don't think there's any part of it that you can look at without saying, well, that's different. Or without wondering, how might my team use this to their advantage in the field? Or a couple of fair questions might be, why this and why now? Well, we're going to give you a full tour of the Tritan today. But to tell the Tritan story, we really need to take a little trip down memory lane to help you understand where we came from and how we got here. Because there were some pretty significant and groundbreaking products that came before the Tritan that lend themselves directly to the Tritan's design. Let's start by going all the way back to 1991. Now, this year is significant to me personally because this is the year that I came to work at McElroy. But more importantly, this is the year that you see Penny McElroy here, who, if you didn't know Penny, along with her husband Art McElroy, founded this company back in 1954. She's pictured here in the UK with a 618 Automac. Now, this is our first automatic machine with a self-retracting heater, and is really the product that got our foot in the door in the UK market. And when you think about it, this was really a lot of technology for 1991. Then in the mid-90s, we launched the very first McElroy Datalogger. Now, the Datalogger may not have even come up on your radar in the UK since you were automatic, but this was the state-of-the-art in portable handheld electronics at the time. And it even came with a tiny little thermal printer so you could print out your joint reports right on site like a credit card receipt. It made record keeping pretty messy, but it was what we had to work with at the time. So as a company in the mid-90s, we were in full-blown product development mode. Technology was getting better and better. Then in 1997, 1998, we rolled out the TrackStar 500. That was over 25 years ago. You might remember the coach control system with the pendant and control box. But as cool as this thing was, it was a product that nobody was asking for, and the market didn't necessarily know it needed when we launched it. This thing really took some innovative thinking and was probably a little bit ahead of its time. And people were asking themselves the same questions I posed to you at the start of this presentation. Why this and why now? And how are we going to use this thing in the field? But you figured it out, and it was a huge success. And the TrackStar 500 was so successful, in fact, and it was innovative enough that you allowed its use in the UK even without the self-retracting heater. And we eventually did develop an automatic version just for you. So as the TrackStar line continued to develop and really changed the way we approach fusion, along comes the Talon 2000 in 2013. Now, not only did the Talon turn fusion upside down, literally, with its bottom-loading jaws, but check out the cool touchscreen digital interface that mimicked the functionality of our conventional hydraulic controls. And it also brought data logging along with it. But there's a lot of technology here in the Talon that you can't see, but you can experience. It has proximity sensors, programmable logic controllers, remote cameras, and even collision avoidance. Fusion machines are getting a lot more intelligent at this time. And think about what was happening with portable electronics, say in the last 15 years or so. Think of cell phones as an example. Each new phone is better, more powerful, and more capable. And as portable electronics evolved, we benefited from those advancements and evolved right along with them. In 2017, we launched the Datalogger 6, which sent us into a completely new era for data recording and managing fusion information. And these handheld tablet computers are getting more powerful and more capable. It was the power of the Datalogger, the success of the TrackStar, and our experience with automation that enabled us to launch the TrackStar I-Series in 2021, right in the heart of the pandemic. And its success has far outpaced our original expectations. And using the power of the Datalogger 7 as the primary user interface, with the Fusion Guide Control System offering 3 levels of operator interaction, including fully automatic, this technology allowed us to build a single machine platform and supply it to a global market. So regardless of your chosen fusion standard or automation requirements, there's one machine for the world, and that is a win-win for everyone. New products aren't easy. The status quo is easy, but as you can see, for over 30 years, we as a company have continued to push forward, exploring the possibilities, investing in the future, and leading the way in the markets we serve. And each of these new technologies we've discussed today represent significant investment. They required innovative thinking, and they brought challenging obstacles to us that had to be overcome along the way. So it's really not surprising that today we're bringing you the new and revolutionary Tritan 560, the future of fusion. So what were our goals when designing the Tritan 560? We had already optimized the fusion process itself. So we wanted to minimize the time spent between fusions. we needed a better method to meet the pipe where it lays, looking for a more efficient way to get the machine onto and off of the pipe. We wanted to handle the pipe less on the job site. We'd like a better way of accommodating tie-ins or doing confined space work. And as always, we wanted to increase the level of performance and productivity in the field. Now, keep in mind that we didn't start shipping the very first TrackStar I-Series machines until April of 2021. But 8 months prior to that, here you see some of the original sketches of the Tritan 560 concepts, dated 24 September 2020. Note that one of the sketches is even titled Talon version 2.0. So from sketches in a notepad in late 2020 to orders on the books and production scheduled for delivery in 2023, that is what I call driving forward with innovation. And that is what's helping to move our industry forward. So let's take a look at the Tritan design, starting with the arms and the carriage. The arms are built for positioning the carriage over the pipe. They offer us the ability to raise and lower, extend and retract, and knuckle up or down for adjustability. And as you can see, the carriage is bottom loading like the Talon. So once a fusion weld is completed, the pipe can remain in position and the carriage can simply be raised up clear of the pipe so the pipe can be pulled through the work zone, or the machine can be repositioned for the next joint. There's no lifting the pipe up free of the jaws, no overhead lifts to load the pipe into the machine as you would with a legacy machine. In terms of diameter capabilities, the Tritan 560 will fuse pipe and fittings from 315 millimeters on the smaller end through 560 millimeters on the larger end. So for reference, it's larger than our TrackStar 500, but not as large as our TrackStar 630. We accommodate different diameters by adding upper half circle inserts and lower quarter inserts for the different sizes. The carriage features a solid full-length guide rod, allowing us to operate in either a 2+2 or a 3+1 configuration, with 2+2 meaning 2 fixed jaws and 2 movable jaws, and 3+1 meaning 3 movable and 1 fixed jaw. Typically 3+1 would be to accommodate T's or elbows. The carriage can be removed from the indexer and the arms for special operations such as in-ditch, tie-ins, or confined space work. And with the carriage removed, it can operate in either a bottom loading orientation or can be turned upside down for conventional top loading setups. Moving on to the Tritan 560 vehicle. The general styling of the Tritan just builds on the history and basic design of most McElroy equipment, but the vehicle features a very unique 360-degree rotating frame. This allows you to fuse pipe with the tracks either parallel to the pipe on either side of the machine, or with the tracks perpendicular to the pipe for the ultimate in setup flexibility. Here you can see the tracks oriented perpendicular. You would pull into the workpiece, fuse the pipe, or alternately with the tracks parallel to the pipeline. This might be used in a pipelining type operation where you're moving the machine from joint to joint. At the rear of the vehicle, you can see the vehicle display. Similar in function to the TrackStar I-Series, where the operator can access machine information and operate the track control functions. Unique to the Tritan 560 is a hydraulically powered generator that gives us a very innovative way to control heater power. Rather than energizing and de-energizing a contactor around a desired heater temperature, the heater is controlled by varying the speed of the hydraulic motor driving the generator to meet the ideal current needed to maintain a constant temperature. Now, that's just a fancy way of saying this allows the heater to stay energized and at temperature without cycling on and off around a set point. The Tritan is powered by a Kubota turbocharged 1.8 liter Tier 4 Stage 5 diesel engine, and the undercarriage is equipped with higher speed track drive, actually the fastest of any of our tracked offering. The Tritan 560 operator interface will be fairly familiar to any I-Series users, but with some valuable additional functionality. The Datalogger wirelessly controls all the machine and fusion functions using its own Wi-Fi network, allowing the operator the flexibility to position themselves for maximum safety and ideal visibility relative to the machine. The various machine functions are integrated within the fusion screens. The operational screens change and can be customized depending on need, with the ability to perform multiple functions simultaneously. For example, you can extend or raise the boom while operating the tracks, or you can open or close the jaws while operating the carriage. The fusion operation flows in the same manner as the TrackStar I-Series software. The Fusion Guide Control System provides the ability to perform level 1, level 2, or level 3 fusions. All the fusion information is recorded for vault storage, and if wireless Wi-Fi communication isn't allowed on site for whatever reason, you do have the ability to tether the tablet to the vehicle or the carriage in special situations. Just to be clear, it doesn't require Wi-Fi access on site. It has its own Wi-Fi network to communicate between the vehicle and the Datalogger tablet. So how are we going to actually use the new Tritan 560 to our advantage? Let's walk through some real-world site scenarios showing examples using conventional machines, and we'll discuss how we might address the same conditions differently with the Tritan 560. Let's start with accessories. Now, I believe that most, if not all, accessories you already use, like pipe support stands, low-profile rollers, the poly horse, or even pipeline cones, will be just as useful and effective with the Tritan 560. Now, you may choose to use them somewhat differently with the Tritan, but they'll still enhance your operation. Here you can see the Talon 2000, the first of our bottom loading machines in a pipelining operation. Now, don't worry about the diameter of pipe in these examples. Instead, I would ask that you focus on the type of job setup. This is a pipelining on a rather narrow winding road. Now, the Talon, as you can see, straddles the pipe, which works quite well and minimizes the need for lifting the pipe over and into the machine. But in this case, the machine would need to be lifted off of the pipeline after the final fusion's made. The Tritan, in a similar setup, could operate in the same environment, but the vehicle would be alongside the pipe with the tracks parallel to the pipeline. Here is another pipelining type of operation. This is as typical in our West Texas oil fields, where the fusion machine is moved from pipe to pipe. You can see some of the timbers and pipe handling equipment on site here. In the case of the Tritan, this would probably be an excellent application for low profile rollers or those pipeline cones that I showed earlier, where you could have a piece of pipe handling equipment working ahead of the fusion machine, setting the pipe appropriately in orientation one end to another, so the fusion machine could be driven down the length of the pipe from one connection to another. Here you see also a fuse and pull type of orientation. A little bit different. We're working off of a pipe stack in this case, with an auxiliary machine used for loading pipe into the machine. In this case, it lifts it up off the ground, over the machine, and into the jaws. With the Tritan 560, I would expect a similar type of setup, but the pipe would simply be lifted off of the stack and set either on low profile rollers or on a pair of pipe support stands. So the pipe would be fully supported just off the ground. You could work in a lower orientation to the ground with the Tritan, but you could work at a comfortable working height. And again, the operator, rather than being tethered to the machine controls, would be wirelessly connected to the machine, so they could keep themselves in a safe orientation to the machine while that pipe is being lifted into position. Similarly, with the polyhorse itself would be replacing two of the pipe support stands or low profile rollers we discussed in the previous example. The Tritan 560 would simply pull up to the fully supported pipe, carriage be lowered onto the pipe, fused in place. Once the fusion joint is completed, the lower quarter jaws or inserts would be opened and the carriage simply lifted straight up over the pipe, and the pipe could be pulled through the work zone with very little disturbance to the freshly fused weld, as well as having the machine clear of the pipe to prevent any damage. Here's an in-ditch example or confined space work. This happens to be in a trench box with a 618. You can see there's extensive excavation underneath this pipe, probably more than was even necessary. But with a legacy machine, you do have to have a reasonable amount of excavation under the pipe, so this carriage can be lowered down below the pipe and then raised back up, clamped on the pipe, the fusion joint made, and then unclamped and rolled out from under the freshly fused pipe. You also would need a man in this space to operate the manual hydraulic controls. With the Tritan 560, you could imagine simply lowering the carriage down from above and clamping onto the pipe, fusing the pipe wirelessly, and then once the joint's complete, simply open the jaws and raise the carriage straight up without that rolling action, taking either those upper jaws or the hydraulic controls down below the pipe into what is typically a muddy trench. And so much simplified operation for Tritan in the in-ditch or confined space work. Here you see another example. This I'm calling fabrication, but really if you're just working with fittings and headers in the field, this I count 3 excavators here supporting this pipe in a coordinated lift. It's a rather complex workpiece. but they've got a coordinated lift up relatively high off the ground to meet the center line of the fusion machine. The fusion machine is then pulled into place, or the workpiece set into the jaws, and then the operator has to get into that area to fuse the pipe. I could imagine a similar setup for this operation, placing this entire workpiece on low profile rollers, for example. So there would be no coordinated lift. There would be no lifting the workpiece up over the jaws to place it into the machine. And the Tritan 560 could literally be driven into place, each connection fused, with the workpiece remaining stationary and the operator able to orient themselves safely in relation to the workpiece. Here's another example. This was actually from the UK, I believe. Some fitting fabrication work. They're making a connection to, looks like a T or a Y, but you can see how with this Trackstar machine, the fusion machine had to be oriented in relation to the workpiece, and where that placed the operator in relation to that lifted and supported pipe. With the Tritan 560, both the fusion machine and the operator could be completely outside of that confined space in a much more reasonable working position. Another confined space example. This is quite complex. We have several connections to make in this case. You can see this pipe is bound. It's being pulled in multiple directions to provide adequate clearance for this fusion machine to be loaded down onto and rolled underneath that pipeline. Quite a complex operation. And then you can see the confined space that the operator would need to be working in to perform this fusion work. This is quite tight, quite complex. There's sort of a lot of moving pieces to this, if you will, although they're not moving. There's just a lot of things to coordinate and consider when getting the machine onto and off of this pipe. It's one thing to put a machine in this position and make the fusion joint. It's quite another to then get the machine out from under that pipe so you can move on to the next joint. With the Tritan 560, the machine could simply be lowered down onto the top of the workpiece from above. The quarter jaws would close around the bottom, and the operator again could orient themselves safely and giving themselves good visibility to make that fusion connection. More in-ditch work here. As I consider this, I see that this particular operator chose to take a 4-jaw carriage into the trench, leaving the heater and facer attached to the indexing carriage, which works quite well for the fusion operation because it gives them the advantage of hydraulically pivoting the heater and facer into position. But look at all of the additional excavation that was required to accommodate getting this machine onto and then back off of the pipe to be fused. Now, time is money, and this is a lot of additional excavation required to accommodate this operation. Again, as I consider the Tritan 560, it would simply be lowered down from above, clamped, fused, and then lifted directly up and off of the workpiece. I will note that when you take the Tritan 560 carriage off of the vehicle, it does not come off with the indexing carriage for the heater and facer. So for in-ditch or confined space work, the heater and facer would simply be lowered in from above. And if you haven't had the pleasure of performing this operation. I just included this picture so you could see really what's involved in getting one of these larger diameter carriages onto and off of a workpiece. I count 5 men here in a confined space with the carriage being lowered into or up off of the workpiece. Very awkward position. You can also see some of the hydraulic clamping cylinders in the orientation at the bottom of this picture, and those would need to be rolled down underneath that pipeline in order to get this machine clamped onto the pipe. We don't have any of that with the Tritan 560. Again, simply lower it down from above, clamp, fuse, and come straight up and off. And here's something quite familiar to this audience. This is working in a shelter or a tent. This happens to be with the MegaMac Polyhorse, but it could be any type of setup. And as I consider how we might accommodate tented or sheltered fusion with the Tritan 560, it would work in a very similar fashion. This is just an illustration of how we might accommodate it. Please forgive the open sides of the tent or the sheer walls. This was done just for illustration purposes so you could see kind of what's going on in there. Note that the Tritan vehicle, unlike the Trackstar, the Tritan vehicle could be outside of the tent. Think about what that would do for the operator's comfort and ergonomics, to remove the noise, the exhaust, the vibration from inside the tent. I think would be very beneficial. And I think with a little creative tent rigging, you could accommodate this type of setup quite easily while providing the operator more than adequate space inside of the tent to facilitate the fusion. And we've also, this is not a great picture, but we've accommodated things like if you were working in a tent, you might need light. Well, we've got a very efficient set of LEDs that are built into this carriage to accommodate low light situations, to ensure that you've got very good visibility all the way around the pipe being fused. There are also work lights or drive lights on the vehicle all the way around the machine. So you've got 360-degree lighting on the vehicle itself. Let's take a look at just some of the weights and dimensions. It's coming in just under 4,000 kilograms, and you get the general size of it here. I won't go through the dimensions, but you can see on the left-hand side of your screen is the Trackstar 500. On the right is the Trackstar 630. As mentioned previously, the Tritan 560 fits nicely in between those two packages in terms of size and in terms of price. The next several slides will just give you some indication of the range of motion of those arms, with the boom extended and retracted, with the carriage lowered and raised, and with the carriage curled up or curled down. This is just hopefully, as I'm scrolling through these, you can begin to envision the motion that we get in this machine. We are also able to position the carriage actually below grade. This is what enables us to work on slopes or uneven terrain if necessary. So various orientations. Hopefully that's scrolling okay for you, just so you can see that range of motion. Here's an overhead view, and you can see also the tracks in that orientation parallel to the pipeline in this illustration on the right. Now, we introduced the Tritan 560 at Infusion 22 here in Tulsa. This was last September, October timeframe. So I can't tell you the excitement that was felt at that time. As you look at this picture, this is the original introduction. I can't count the number of cell phones that are up taking videotape of this launch. While we were in the launch, people were on Facebook Live. They were simultaneously posting this innovation to social media. Before we could even finish our presentation, the Tritan was out there. And as they were looking at it, you see we have them kind of roped off here, giving us clearance to operate the machine and show off some of its capabilities. But the audience was quite in awe. But the excitement really began to build when we let them through the ropes and they could get closer to the machine, and they began to think about, how am I going to use this? And they were discussing past projects and how the Tritan 560 might have helped them over some of the challenges that they experienced previously, or they were considering future projects and how the Tritan might enable them to more effectively address the situations and field challenges that may be upcoming. This reminded me very much of that original launch of the Trackstar 500. People weren't asking for it, but once they saw it and got their hands on it, you know, we as a company had a vision for what the Trackstar might become, or what we might be able to accomplish with it in the field, much as we do the Tritan 560. But I will say that the reality of what our customers have been able to achieve with the Trackstar in the field has far outpaced, you know, our original vision. And I believe the Tritan 560, when we get it in your hands, what you're able to achieve with it, again, will far outpace what our vision and expectations are for the machine. So I'm excited to get one of these into Europe. We do have one on the way. That is the end, Alex, of my formal presentation. If you'd like to open up the floor for any questions we have, or make some comments based on the presentation.
Yeah, sure. Thank you. Thank you very much for the presentation, Chris. I think it was quite well. I just wanted to let you know that we will have our own Tritan 560 demo machine towards the end of the year in the UK. So everyone here is welcome to come to our Milton Keynes office to come and have a feel for the machine, a play with it. And yeah, I would like to open the room. If there's any questions for Chris or any questions for me, we're more than happy to ask them now.
Alex, while they're considering questions, I'll just say I am truly excited to get over to the UK with the Tritan 560. I know it was a ton of fun taking the I-Series in and you know, working through that launch, and to see the success that the I-Series machine has had, and as innovative and forward thinking as the Tritan 560 is, I think it's just going to be a very exciting time to be involved in this industry and with this product.
Yeah, I agree. I think I think it would be great to have you here in the UK with our demo machine and having this demonstration live. I think we have a question on the chat. So Andy Farnfield is asking, for in-trench applications, what is the approximate weight of the lift into the excavation?
The weight of the carriage itself, I don't have that data, but I can certainly get that. We've built several prototypes of these machines, and with each prototype, we end up, improving the design somewhat. So we're just now finalizing the designs, and we'll get final weights on those once they're complete. But I don't recall the approximate weight. It would require assisted lift, though. It isn't anything you could put into the trench by hand.
Yeah, you'll definitely need some supporting equipment for in-trench applications.
For the carriage, for the heater, and for the facer. I don't think any of those will be a man lift type of operation.
Understood. Thanks, Chris. There's another question from Lance Watterson. He says, what is the SDR range that the Tritan 560 can operate with? A lot of the pictures seem to be using thick wall pipes.
Yeah, we don't have any limitations at this point in terms of SDR. We have a single cylinder setup, and with the Tritan 560, we have the pressure control functionality to accommodate all pipe diameters within the diameter range and all SDRs. At this point, we've not come up against any limitations.
Yeah, and it's a bit of a two-part question. So he asked later, what ambient temperatures can the Tritan 560 operate in?
Well, we have yet to perform our environmental testing on the Tritan 560. Many of the components used in the 560 are of similar or common orientation to the TrackStar I series. All very ruggedized controllers, valving, those types of things. And the TrackStar I series has performed very, very well in environmental testing and extremes. I expect the Tritan 560 will as well. If you have some specific extremes that we need to be considering on this end, I would love to have that information. Perhaps after this meeting, Alex, they could share those with you.
Yep.
But we expect this machine to operate all around the world in all environments.
Yeah, that's also something very important, I think, to mention, that I'm the eyes for the UK market. So if you have any specific requirements or anything that you reckon, I can speak with Chris and the engineering team, and we can certainly make them know about those requirements. With that, we have another question from Andrew Young. He says, we cannot load the sides of our excavations within 1.5 meters. So will this impact on the depth that can be achieved for in-trench work?
Hey, Alex, I'm not understanding the question. Can you clarify?
I'll repeat it. Yeah, it says we cannot load the sides of our excavations within 1.5 meters. So will this impact on the depth that can be achieved for in-trench work?
So am I understanding they can't have anything atop the trench within 1.5 meters?
Yeah.
Yeah, you would have in-ditch extension hoses. It's similar in in-ditch functionality to what we have with the TrackStar machines. So if that's not a limitation for your TrackStar machines, it wouldn't be a limitation for the Tritan 560 either. If it is a limitation for the TrackStar I series machine, I need to understand a little bit more about what he's trying to describe here to see how we might accommodate it with the 560. Yeah.
Yeah. As Chris mentioned, the carriage can be removed, and then you can attach an extension kit, and 1.5 meters shouldn't be an issue. So I hope that answers your question, Andrew.
I love getting questions.
Yeah.
That's nice.
We got a couple of them. Yeah. Okay, I think if we don't have any more questions, and everyone is happy. Here you can find my contact details. Me and Malcolm will be more than happy to answer your questions. If we can answer them, we will redirect them to Chris. But yeah, just wanted to thank you, everyone, for attending today and for being part of this webinar. And please do let us know if you need anything else from our side. And yeah, thank you very much, Chris, for joining us and explaining us.
Certainly. I want to personally thank each of our attendees, and again, thank the Pipeline Industry Guild for this opportunity. I would love to be able to come back to this audience once we have the Tritan 560 in the field and share with them some of the initial field experiences and just kind of bring some follow-up messaging to this audience relative to the Tritan.
Thank you, Chris.